All right, so we're going to continue chapter 7 and looking at our systems and matrices. This time we're going to look at systems of inequalities, which you solve by what we call linear programming. So many mathematical things are like no more than or no less than, and you're trying to find the smallest cost or the highest production rate or all of that. So you end up writing inequalities instead of equations, and then we use linear programming to solve it. So a line divides a thing into 3 points. You have points above the line, points below the line, points on the line. This would be greater than, this would be less than, and so on and so forth. A linear inequality, you can write it just like a linear equation, just has an equal sign. And your answer is that half plane. It's the side that's shaded in. So if first we graph the line, 3x minus 2y equals 6. Then, if you know which side to shade, go ahead. If you're not sure, I test a point. So this one, 0, 0 is really easy to test. So if we plug that in, we would get 0 is less than or equal to 6. That is true. 0 is always less than 6. So we're going to shade the side that has 0, 0 in it. That's how you can graph your inequalities. So graph the line, test a point, shade the side. If you have one option to graph is solve for y. So here they subtracted x from both sides, divided by 4, and then they could graph that line. If it is less than or equal to, greater than or equal to, you have a solid line. If it's not equal to, you do a dashed line like this picture here. Then test a point. So if I plugged 0, 0 into this, 0 is greater than 4. That's never true. So we shade the side that doesn't have 0, 0. When it's written as y equals, then you can go by the greater than or less than. That makes it really easy to decide above or below. On your graphing calculator, you can set this. So if you go to y equals, and then you arrow all the way before to the enter, you can change this line. So older graphing calculators, you hit enter a bunch of times and it'll change it. Here, you're going to choose a greater than or a less than. If you keep going, it's less than. Then hit OK. When you graph, it'll shade above or below the line for you. Desmos does the same thing. So if I were to write y is, this time we're going to use a less than 2x, it'll shade. If you used less than or equal to, it'll put your dotted line versus your dashed line. So you can graph these same way you graph anything else. Desmos, if you're just typing, you're going to use these. Otherwise, it has the buttons for you. Cannot be solved for y. So yeah, if you can't make it say y equals and just do above or below, you test the point. We just talked about that. Graphing a rational inequality. So first, graph it like the equation. Then test a point in the intervals, just like we've been doing. So if you tested a point in this interval, it'd be 0. 1 over 0 minus 1 is 1 over negative 1. Is that greater than, what do we plug in? 0. Is 0 greater than or equal to negative 1? That is true. So we're going to shade above the line up to our asymptote. Then on this side, let's do 3. So is 3 greater than or equal to, oh no, that's our x, greater than or, oh my goodness, I did that crazy. Yes, okay, so if I plug in 3, whatever, if I plug in 3, 1 over 3 minus 1, we get 1/2. So 1/2 would be about here. If we tried 2, 1 over 2 minus 1, 1, that is not, right? That dot is below the blue line. It's not true, so we have to shade above the blue line. They tested any random points. just a point in the region. If it comes out true, you shade where the point is. If it comes out false, you shade where the point isn't. It's not a big deal. Dashed lines and boundaries we talked about. You can do this with any. If you have a system, you graph them both, and then the shape part that they overlap is what's true. You can do this on your graphing calculator. Put 1 in as y1, put 1 in as y2, use those boundaries, and then your answer is going to be this part here that has both pieces shaded. Desmos, same thing. You can type them in, and then the answer would be these parts that are shaded with both colors. You guys try this one. Graph those 3. Whether you do it on the calculator or by hand, it's up to you, or the computer. So here, the blue line is this, and it was greater than, so we would shade all of this area, which they did on the calculator. The green one was this bottom, and if we rearranged it, it was y is less than, so we would shade this side. And then the middle one's the circle, and we said less than, so that means it's within the circle. So that's where we get those 3 colors. And then the part that has all 3 would be the answer. So this piece in here is the actual solution. That's where all 3 are true. You can, again, do the same thing on Desmos. So linear programming is how you find the minimum and maximum profits. So the first thing you're going to do is you're going to find the area. You're going to graph all the equations from the word problem. And then you're going to find the corners and test those. So let's start with this. Company makes 2 products, MP3 players and Blu-ray players. So if they're making things, can you make negative? No. So if X is MP3 players, X has to be greater than equal to 0, and so does Y, because you can't make negative things. We know that already. Each MP3 player gives us a profit of 30, while the Blu-ray produces a profit of 70. So $30 per MP3 player plus $70 per Blu-ray player is going to give us our total profit. The company must manufacture at least 10 MP3 players per day for one of its customers. So X has to actually be greater than or equal to 10 because they have to perform that many. So we don't need this 0 anymore because we know we're higher than that. But no more than 50. So it also has to be less than or equal to 50 because they don't have the materials or whatever to make enough. Blu-ray players cannot exceed 60. So it has to be less than or equal to 60. Oh, that's Y. Sorry. Less than or equal to 60. And the number of MP3 players cannot exceed Blu-ray players. So they have to be, MP3 is less than or equal to Blu-ray. So a lot of information, but just for each thing you're going to make an inequality. Then we're going to graph them. So I'm going to write them again over here. We said 10 is less than or equal to X, which is less than or equal to 50. So if we did 1, 2, 3, 4, 5, 6, 7, 10, if we made these 5, 10, 20, yeah. So this would be 10, 20, 30, 40, 50. We know we have to be somewhere in between these 2 green lines. Then we said, what else did we have? Y was less than or equal to 60. So if these go by 10, 20, 30, 40, 50, 60, Y has to be less than this blue line. We also said, we did that one, we did that. Y has to be greater than 0, okay. And then X has to be less than Y. Less than or equal to Y. So if we graph X equals Y, that's this right here. Hold on. Right there. And remember we said if the Y was first, we could shade above. So it's going to be this side of the yellow. We said it has to be between the green, below the blue, and this side of the yellow. So that shaded area meets all of our needs. Now we're going to find the coordinates of each of these points, each of the corners. So this is 10, 10. This is 50, 50. This is 50, 60. And this is 10, 60. So I read the word problem to come up with my inequalities, graphed the inequalities, found the corners. If you use Desmos, just graph them all, write them all on the side over here, and then you get those same things by hovering over those gray points. It'll give you the same coordinates. Now, to test these, we're going to use that profit equation. So we said it was, what was it? 30x plus 70y. So 30x plus 70y is our profit. This is going to be our x, this is going to be our y. So I'm just going to write those points. We had a 1010, we had a 1060, we had a 5050, and a 5060. So if we plug these into that profit equation, we would get, so 30 times 10 is 300, and 70 times 10 is 700, and if you add those together, you get 1,000. If we plug in 10 and 60, we get 4,500. So we're just plugging them into this equation here. So if we plug in 50/50, we get 5,000. And if we plug in 50/60, we get 5,700. This is the highest profit. So 50 MP3s and 60 Blu-ray per day will give us the biggest profit. That's what we're doing. If there is an optimal value, it's at the corners. So if you have a closed shape, you find each corner. If it's an open shape and everything goes on forever, you just find those break points along the edge that you can get from the axis to the axis. So you guys try this one. Try making your equations, try graphing it, and then watch me go through it. So, Robin gives her dog Susie vitamin supplements every day. She has minimums of what she wants. So 16 vitamin K, 5 vitamin B1, and 20 riboflavin. So, if what did I do here? Made a table. So I'm going to make a table. It's going to make life easier. So we want K, B, and ribo. The minimum amount we want was 16, 5, and 20. So we have to have that much. Now, she can choose between two brands. Brand X costs 10 cents. So brand X costs 10 cents. Has 8K, 1B1, and 2 riboflavin. 8, 1, 2. Okay. Now, brand Y costs 20 cents. Has, let's see, 2K, 1B1, 7 riboflavin. 2, 1, 7. How many of each pill should she buy to minimize her cost? So you want to minimize cost. And they give us the cost function right here. 10x plus 20y equals our cost. Because it's 10 cents for each x, 20 cents for each y. So, if we buy, for our k, we have one inequality. We need 8x plus 2y, and that has to be greater than or equal to 16. Then, so that's this. If I solve for y, I subtract 8x from both sides. Divide everything by 2. Now we have a line we can graph. So y is greater than or equal to 8 minus 4x. That was 1. Now let's do b. We have 1x and 1y, and we need that greater than or equal to 5. So that's our other equation. Oh, well, let's solve for x. Bring y over. So y is greater than or equal to x, 5 minus x. All right. Then we're going to do our riboflavin, which would be 2x plus 7y needs to be greater than or equal to 20. Subtract 2x from both sides. Divide by 7. We get 20 over 7 minus 2 over 7x. 20 over 7 minus 2/7 x. And we know we can't have negative amounts because you can't take negative something. So x has to be greater than 0, y has to be greater than or equal to 0. So now we have our equations and we can graph them. So if I graph this one, the white yellow one, y intercepts 8, then we go down 4 over 1, down 4 over 1. Here's that line, and it's greater than, so it would be anything on this side. Now let's do the pink one. 5 minus x, so we go here, 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 here. Graph that. Greater than, so anything on this side. Now let's do the purple. So 20 over 7 is around here, above 2. And if we plot points, so if I plugged 1 in, I plugged 2 in, found a bunch of points, we end up with 10, 0 over here as our intersection. So we'd have this. And it would be anything over here. And we know they're above 0, so our solution falls anywhere above in this picture. And it goes on forever. So our corners are going to be each of these points of intersection with either the axis or the other lines. This point is 0, 8. This is 1, 4, 4, 1, and 10, 0. So again, if you graph those on Desmos, you can find them by hovering over the gray points and you would get those same coordinates. If you graphed it on your calculator, same thing, you can find the intersection points. Then we make a table. So we plug each of those points into our cost function. So if we plug in 10, 0, that ends up costing us $100. If we plug in 3, 2, costs us $70. If we plug in 1, 4, costs us $90. If we plug in 0, 8, it costs us $160. And they want to know what the minimum is. So that would be the $70 one, which means they're giving 3 of brand X and 2 of brand Y every day to meet her minimum requirements at the lowest price. So yeah, we could do it up here and go way above the minimum requirements, but that's going to cost more. This point meets the minimum requirements, but costs more than double. So that's the point of this linear programming. You graph you read the problem and write your equations. So read and write your inequalities. Qualities. Then you're going to graph each one. Then you're going to find your corners. Then you're going to test each point with the equation. And then choose whichever one is either the highest or lowest based on what the question's asking. So that is the end of 7-7. Let me know if you have questions.